Hello everyone. This video is on the Knewton Alta assignment for section 6.1 called Adding and Subtracting Polynomials. So in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same and the structure of the problem should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Now on your assignment page you should be seeing the title, the mastery bar, which tells you how far along you've gotten, the objectives. Looks like there are 4 objectives for this particular assignment. Under the current objective, you'll have a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not see this instructor cheat button. No, it's instructors only. But you will have a more instruction button. If you're ever struggling with a topic or a question, click on this and you'll be taken to a page with some reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so before I actually get into this objective here, I do want to talk about, you see there's things called monomials and polynomials, and they talk about types and degrees. So before I get into actually adding and subtracting monomials or polynomials, I want to talk about what these things are. Right? So some definitions. All right, a monomial. All right, a monomial. Mono meaning one. It's like a one-term polynomial, we'll see later. But a monomial is simply a product of a constant, alright, so some real number, just a number, a product of a constant and variables raised to whole number powers. Whole number exponents. Right. So some examples of expressions that would be considered monomials would be the following. Say 7 times x to the third power, times y. Y to the first power, right? As long as the powers are all whole numbers, there's no fraction powers, no negative powers. Right. Remember, the whole numbers are 0, 1, 2, 3, and so on. Right. There's no negatives, no fractions. So this is an example of a monomial. Another example would be, x squared divided by 2. This is the same thing as 1/2 times x squared. Right. It's a number, a constant, times a variable to a whole number power. Negative 14, times xyz. There's a number, negative 14, times variables to whole number powers, x to the 1, y to the 1, z to the 1. Right? And then here are some examples of things that would be not considered monomials. So like say 2 times x to the negative 4. Right, you see how the variable has a negative power. That's not going to happen in our monomials here. Right? Got to be whole number powers on the variables. Say just negative 1/3 times the square root of x. Now you may have heard this before, you may not have, but the square root of x is actually the same thing as x to the 1/2 power. But you're not going to see special symbols. You know, there's a special symbol there like a square root or absolute value. You know, you're not going to see special symbols in a monomial, or you're not going to see fraction powers in a monomial. You're not going to see negative powers in a monomial. And then one last example of something that's not a monomial would be like 5 divided by x. Right? Remember I said earlier it's a product of a constant and variables raised to whole number powers. This is not a product, it's a quotient. Right? It's not multiplication, it's division. Now you could also write this as 5 times x to the negative 1 if you know your negative powers, but either way it's not considered a monomial because you have a variable in a denominator. That's not going to happen in a monomial. And once again we see that it's equivalent to something with a negative power on a variable, which is also bad. Right? So no negative powers, no special symbols, no fraction powers, no variables in denominators, none of that stuff is happening in a monomial. Alright, and then something else to go along with this, another definition. So I keep the word monomial up there. The degree of a monomial the degree of a monomial is just the sum of the exponents on the variables. It's that quick. Basically the number of variables that are in the product. Because remember, x cubed is x times x times x. That's 3 x's and then a y to the first. So this would be a degree 4. Right? A quick way of saying that though is just add up the exponents, the sum of the exponents on the variables. Right, that's the degree. Right, so for example, this monomial that I first gave you, 7 times x cubed times y to the first, this would be degree 4, right? 3 plus 1, the sum of the powers. This one, the x squared divided by 2, or the half x squared, same thing. This would have degree 2, right? Because the only exponent on a variable is 2. And then this last example, that's x to the first, y to the first, z to the first, 1 plus 1 plus 1. This is a degree 3 monomial. And one note about degrees is that constants have degree 0. Right, so for example there, if I just said, here's the number 8, that's a monomial. That is a monomial. And it has degree 0. Right, because there are no variables to powers. There are no variable factors in that term, in that monomial. And other numbers just on their own, if you have just a number by itself, a constant, that's got degree 0. Okay. The only number that doesn't really work for is 0. The number 0 could have like any degree technically, but we're not going to get into all that. Alright. Now, monomial is defined here. Degree of a monomial is defined here. Now we'll get into polynomials, which is just many monomials. Poly means many. So a polynomial is just a sum of monomials. Or it could be a monomial as well. A monomial is called a polynomial with one term. But polynomials, so one more definition here. A polynomial is just a sum of monomials. And the number of monomials is called the number of terms. Right? Each monomial is a term. Right? You see the word terms. So a monomial is also a term of a polynomial. So for example, 3 times x, that's a polynomial with one term, right? Every monomial is a polynomial with one term. Mono meaning one. 5 times xy plus 4x cubed. This is a polynomial with two terms. I have a monomial, 5xy, plus another monomial, 4x cubed. Then here's, how about say, negative 2xy squared minus 7xyz, z squared, whatever. And how about I throw on plus 3? Right? Why not a constant term? But here's a polynomial with 3 terms. Monomial. Now technically minus is plus a minus, adding a negative. You could also write this as plus negative 7xyz squared and then plus 3. So you have monomial, negative 2xy squared, plus another monomial, negative 7xyz squared, plus another monomial, 3. These are all examples of polynomials. Right. And if any of the terms aren't monomials, right, they have a fraction power or a negative power or some special symbol, or if you have variables and denominators, right, all those things I showed you on the first page that made something not a monomial, then you have something that's not a polynomial either. Each term must be a monomial. Right. All right, and then types of polynomials. Types of polynomials. Again, one term, that's called a monomial. Right, you have seen that, mono for one. So this is an example, the 3x here. This is an example of a monomial, as in my previous pages. If it has two terms, right, if you're adding up two monomials, that's called a binomial. So this example here, the 5xy plus 4x cubed, this is an example of a binomial. It's got the sum of two monomials. If a polynomial has 3 terms, right, is the sum of 3 monomials, like my last example here. That's called a trinomial. So this last example is the sum of 3 the 3 monomials, or trinomial. And you can keep going with this. Now after that, they usually just say it's a polynomial with 4 terms or a polynomial with 5 terms. I mean, I guess you could call them like quadrinomial and quintinomial or something like that, but usually after 3, you'll see books just say polynomial with 4 terms, polynomial with 5 terms, polynomial with 6 terms, etc. All right, and then one final definition. Well, actually not a final definition. We're going to talk about things called like terms as well. We talked about the degree of a monomial earlier, right? Just the sum of the powers, the sum of the exponents on all the variables. The degree of a polynomial Alright, the degree of a polynomial is just the largest degree of any of the monomials. The largest degree of any of its terms. Okay, so for example, this monomial here has only got one term, and this should be a degree 1 polynomial, right? Because it's just x to the first power, and that's it, right? Now, if you look at the degree of the terms for this next one, the binomial, 5xy has a degree 2, 4x cubed has degree 3, and the larger of these two is 3. Right? So the degree of the polynomial, the degree of the whole thing, they would say was 3. Right? The larger of the degrees of any of the terms. And this last one, the first term has degree 3. Pardon me. This next term has degree 4. And the last term is a constant, so it has degree 0. And the largest of those is 4. Right? So the degree of this last polynomial, this trinomial here, would be degree 4. All right. Hopefully that makes sense. Alright, so I got a lot of stuff out there, a lot of definitions. Now when it comes to adding and subtracting, like we're finally getting into in this first question, you can only combine what are called like terms or like monomials. Alright, so when it comes to adding and subtracting, you can only combine what are called like terms. Right, and like terms, they have the same variables to the same powers. Have the same variables to the same powers, to the same exponents. Right. And when you combine them, you just combine their coefficients. You don't change the variables and powers. Just combine what are called the coefficients. The coefficients are just the numerical parts, the numbers, the number parts. So our first example here, the very first question we're given, we have 9p to the fourth, that's a monomial, plus 11 times q to the fourth, another monomial, so now I have a binomial, and then minus q to the fourth again. Pardon me. So these two, the first two terms, the first two monomials are not like. They're not like. Sure, they have the same power on the variable, but they don't have the same variable. Right? This term has a variable of p to the fourth. The second term has a variable q, which is totally different. So I can't put these together. I can't add these. So be careful with that. But these two terms, the last two terms, right, the second and third term, these are like terms. They have the same variables to the same powers on those variables. They both have q to the fourth. So when you put those together, I'll do this off to the side. I have a positive 11 q to the fourth, and then we have minus 1 times q to the fourth. See how they both have this q to the fourth in common? And you can almost like reverse the distributive property. Do something called, factoring it out. See, both of these have q to the fourth, so I pull that outside a set of parentheses here, again just kind of reversing the distributive property. And then when I remove q to the fourth, what's left over inside the parentheses would be 11 for the first term and then minus 1 for the second term. And then this is what I mean by combine the coefficients, combine the number parts. 11 minus 1 is 10. So we have 10 q to the fourth. Right? If I have 11 something, so like 11 apples, and I take away 1 apple, I have 10 apples. That's basically what's happening here, kind of like that, described in very simple terms. So when we're asked to simplify this, the 9p to the fourth doesn't go with anything else. So that term, that 9p to the fourth, is going to stay the way it is. And it's these two terms, the like terms, that get combined. The positive 11q to the fourth minus 1q to the fourth make positive 10. Right? So plus 10q to the fourth. And again, the power and variable do not change. Right? It gets pulled out through the distributive property, reversing the distributive property, and then you just combine the number parts. And this is it. This right here is as simple as this would get, because once again, these are not like terms. This has p to the fourth, this has q to the fourth, not the same variable. And that's what I'll type. So after combining the like terms, I end up with 9p to the fourth plus 10q to the fourth, right? I end up with a binomial, two monomials added together, two terms. Then after you submit an answer, you'll be told if you're correct or incorrect. Then you'll be given some sort of answer explanation. Please read through the answer explanations. This one's pretty short, but hopefully you can read through the answer explanations and understand why something was right or wrong, and maybe learn from your mistakes for future questions. Alright, so the next example. Alright, so now we're asked to evaluate a polynomial for a given value. So they give us a polynomial, right, a sum of monomials. This one here is a binomial, right, the sum of two monomials, negative a squared plus c squared. And we're asked to basically plug in values for certain variables and write the final result, write what the result would be after simplifying. So that's what, whenever you hear the word evaluate, right, that just means find the value of, right? So we have to find the value of this expression when I plug in a value for, a certain value for one of the variables. So we have negative 1 times a squared, that's a monomial, plus, and then 1 times c squared, right? So we have a binomial, sum of two monomials. And they're telling you plug in, negative 4 for c. I'm going to substitute in negative 4 for c. So this would be negative 1 times a squared. Right? I didn't replace a with anything, so I'm just going to leave that as negative a squared. And then anytime you replace something, I would recommend putting parentheses around that, just to, it'll make things a lot easier for you, I promise. So instead of c squared, I have, negative 4 squared. And then we simplify. Remember what negative 4 squared means. That means negative 4 times negative 4 again. So that's positive 16. So I end up with negative 1 times a squared plus, and then positive 16. So just 16. And that's it. Right? Because we don't have a value for a. And these are not like terms, right? This has a squared. This has no variables at all. So you can't put these together at all. This is it. Negative a squared plus 16. That's what I'm typing. Negative 1 times a squared, and then plus 16. Great. Okay. Once again, another evaluation. They give us some expression here, some polynomial. This looks like a trinomial, right? They're a sum of three monomials. And there's, some b's and a y, and we're asked to just plug in 5 for b and simplify. Alright, so I'll just do this on the same page here. We're given this expression, 2 times b squared plus b and then plus y squared, right? There's a trinomial. And we're just asked to substitute, 5 for b, and that's it. Nothing for y. So I'm putting in 5 for b there and there, right? Wherever there's a b. So this becomes 2 times, 5 squared plus 5 and then plus y squared. And then remember your order of operations. You raise things to powers first before you multiply. 5 squared is 25, and then times 2 would be 50. And then there's really no need for the parentheses around this because it's not being raised to a power or multiplied by anything. So plus 5 plus y squared. And then these two terms are like because they both have no variables. They're both constants. You can put them together. So 50 plus 5 is 55 for the first term, plus, and then we still had this y squared the entire time. And these do not go together. They are not like, this has a variable y to the second power. This term has no variables at all. So you can't put those together. So this ends up simplifying to 55 plus y squared. 55 plus y to the second. That's it. Great. Or y squared plus 55, right? You can write the sum of the monomials in any order, right? And when you add numbers, when you add real numbers, it doesn't matter what order you put the addends in. It'll still be the same thing. So if you wanted to do y squared plus 55, that was the same thing. Alright, so back to this, just adding and subtracting monomials. So again, we're just combining like terms. So you just gotta understand which ones are like, which terms, which monomials have the same variables with the same powers on them. So here we are given 14 times m. Right, there's one monomial. Plus, and then 15 times p. And then plus, negative 22 times p. All right, and again, these are like. These both have p to the first power. So I combine these, and if you want, the 14m isn't like the other ones, so I'm going to leave it as 14m. And like I said earlier, it's almost like you can pull the p out, right? And then in parentheses, you're just reversing the distributive property. I factor p out, and then inside parentheses, you'd have 15 minus 22. You're just combining the numerical parts. You're combining the coefficients. And 15 minus 22 is negative 7. So we have 14m, plus, and then negative 7 times p. Now, nobody usually writes this plus a negative. Remember, plus a negative is just subtraction. So this is 14m minus 7p. And this is as simple as this would get, because these are not like terms. They have different variables. Right, to the same power, sure, but they're not the same variable. So that's it, 14m minus 7p. So type that in, submit. Great. Alright, so now to type and degree. What's the degree of this polynomial? So remember, you look at the degree of each term, which would be 2, 1, and 1. And then whatever the highest of those is the degree of the whole polynomial. So degree 2 term, degree 1 term, degree 1 term, the largest of those is 2. So this would be a degree 2 polynomial. It's really that easy. Okay. Alright, so now we're just adding and subtracting polynomials. Alright, now pay attention to how they're wording this. They say subtract this polynomial from this one. So I'm going to have negative 8m squared minus 8m plus 12, that polynomial, that trinomial, minus this first one. Because when you subtract like 7 from 10, you do 10 minus 7, right? You do the second minus the first. So I'll just do this here. There's plenty of space. So we're told, take this polynomial, negative 8m squared minus 8m plus 12. And what we're asked to subtract from that, right? So I got minus is this other polynomial. Now notice it's in parentheses. You're subtracting this entire polynomial, the quantity 2m squared plus 10m, and then plus 1. Now, you may have seen this before with subtraction. Whenever you subtract an expression that has multiple terms like this, you're not just subtracting the first term, you're subtracting all those terms. So it's like distributing a -1 to all three of those terms. So what I have is, now you don't need parentheses around this first expression because there's nothing times it, right? Or it's not being raised to any powers. So I can get rid of the parentheses in that first polynomial, -8m squared minus 8m plus 12, and then minus 2m squared minus 10m, and then minus 1. Right? We're subtracting every single term from that second polynomial. And now I have a polynomial with 6 terms: -8m squared, -8m, positive 12, -2m squared, -10m, and -1. Now, as I was saying earlier, you can rearrange a sum in any order you want. I'm going to rearrange them so that we put all the like terms next to each other. So you see this -8m squared, that's going to go with this -2m squared, right? So -8m squared minus 2m squared, right? Because they both have m squared. They both have the same variables to the same powers on those variables. They are like. Then the -8m will go with the -10m. So my next two terms will be -8m and then the minus 10m. Right? Those are like because they both have m to the first power. And then the constant terms, positive 12, -1, so plus 12 minus 1. So this is the same as that. I just rewrote the terms in a certain order so that all the like terms were next to each other. All right, then combining like terms, -8 minus 2 is -10, so we have -10 m squareds. And then the next two, -8 minus 10 is -18 m to the firsts. Right. Again, when you combine like terms, when you add and subtract, that base in power, the variable in power, those don't change. And then positive 12 minus 1 is positive 11. Right. And this is it. This is it. None of these terms are like. Right. This has m squared, but this has m to the first. Right. Totally different power on the variable. And then this term doesn't have any variables at all. So you cannot combine any of these coefficients. You cannot combine any of these terms at all. Alright, so after performing that subtraction, we have -10 m squared minus 18m plus 11. Great. Alright. Okay, back to the types and degrees. This should be simple enough. Is this a monomial, binomial, trinomial, or some other polynomial? Well, notice there's no sum here, right? It's not plus, 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 minus, 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 whatever. It's just a number times some variables to whole number powers. Remember, that was the definition of a monomial, one term. 52 times c squared times y to the fourth. This is a single term polynomial, a monomial, and that's it. Very quick. I feel like that objective is going to be pretty quick. So back to adding and subtracting. So they just write out the subtraction problem for us. Remember, see the minus and then you have this whole quantity in parentheses here. You're not just subtracting the first term. You're going to be subtracting every single term in that. So distribute the negative sign. Distribute the -1. Alright, so I'll write this out. So the first polynomial in this difference is -12 times c squared plus 12 times c times q plus q squared. All right, and then from that polynomial we are subtracting, and then in parentheses this other polynomial, 6c squared plus 8cq plus 6q squared. But as I was saying earlier, right, you're not just subtracting that first term, you are subtracting all three of the terms of that second polynomial. So this is equivalent to the following. Now there is really no need for the parentheses around the first one because it's not being multiplied by anything, it's not being raised to any powers. So we have negative 12c squared, then positive 12cq for the next term, then positive q squared. And then after subtracting every term over here, we'd have minus 6c squared, minus 8cq, and then minus 6q squared. All right, and now I'm going to combine the like terms. Or you can rearrange them. You can do the thing where you rewrite it and use the commutative property to reorder these things so that like terms are next to each other. But I'm just going to kind of underline them. So here are the c squared terms. Those would go together. Negative 12 minus 6 is negative 18. So I have negative 18 c squareds. Right? Then here's a 12cq. And there's a negative 8cq term. Those both have c and q, both to the first power. They're like terms. Positive 12 plus negative 8 is, just 12 minus 8. That's 4. Positive 4. So plus 4, and then cq. Right? Remember, the variables and powers don't change when you're adding and subtracting like terms. And then I have the positive 1q squared and negative 6q squared. 1 and negative 6 make negative 5 when you add them, so I have negative 5q squared. And that's it. All right, this is as simple as that polynomial will get. Because, this has c squared, nothing else even has c squared. This has c to the first, q to the first. Nothing else has c to the first or q to the first. And this has q squared, nothing else has q squared, right? They don't have the same variables to the same powers. You can't combine them. Okay, so the result of this subtraction here, negative 18 c squared plus 4 cq minus 5 q squared. Great. Okay, next. Alright, back to just evaluating a polynomial. So again, we're given some polynomial, another trinomial. It looks like a polynomial with 3 terms. And we're asked to plug in a value for one of the variables and write what the simplified expression would be. So once again, I'll write this out. Alright, so this polynomial is, we have negative 1 times b squared minus 2 times b times x squared, and then minus x, and the value of x is negative 2. Alright, so I'm plugging in negative 2 for x, here and here, right, wherever there's an x in the expression. So the negative 1 times b squared, negative b squared like that, that's going to stay the way it is. Then we have minus 2 times b, but instead of x squared, I make that, negative 2 squared. And then minus, instead of x, minus negative 2. Alright, so this is negative b squared. Now, negative 2 to the second power is positive 4 times negative 2b would be negative 8b. Alright, 2 times 4 is 8, and you have a minus in front still. And then minus negative 2 is plus 2. And there we go. That's as simple as that gets, right? Again, none of these terms are like. None of them have the same variables to exactly the same powers. And there we go. So negative, b squared minus 8b plus 2. All right. Next. All right, so one more evaluation. This one I'm just going to speak out. If I replace c with negative 1, right, negative 1 squared is positive 1, but you still got the minus sign in front here. So that'd be minus z plus, and then negative 1 times z would be minus z again. So you have minus 2z when you combine like terms, and then plus negative 1, so minus 1. Right, negative 2z minus 1 would be the value of this expression when c is negative 1. And then after all the combining of like terms and junk. Alright. Now back to the, again, what I feel is the easy one. Is this a monomial, binomial, trinomial, blah, right? It's the sum of two monomials, right? You have negative 2 times a cubed, b cubed, that's a monomial, plus 15/8 is the coefficient here, times c cubed, z cubed. Another monomial, so two monomials added together, that's a binomial. All right. Again, easy enough. All right, then one more of these. What's the degree of the polynomial? Remember, you look at the degree of each term, and then whatever the highest of those degrees is, that's the degree of the polynomial. So the first term, negative 65b, just has degree 1. All right, that's b of the first. And then 53x cubed y, the powers add up to 4, 3 plus 1. So it's degree 1 term, degree 4 term. The highest of those is degree 4. So this would be called a degree 4 polynomial. All right, great. All right, and then the rest of the time we're adding and subtracting. All right, so once again, I'll just speak this one out. You have negative 6 u squared y. There are no other u squared y terms. There's uy squared, there's u squared y squared, but there's no other terms that have u squared y to the first on there. So that doesn't go with anything. This next term has, negative 1 uy squared. There's no other terms with uy squared. U to the first and y squared. So this doesn't go with anything. And the last term has u squared y squared, and no other term has u squared and y squared. So these three terms are not like. None of them are like. So this, the way they wrote it, is as simple as it gets. So I'm just going to let me see if I can just copy and paste this actually. The way they wrote this is as simplified as it gets. Oh no, that doesn't work. All right. And it doesn't do the powers very well when you copy and paste. All right, so negative 6 u squared y minus uy squared minus 22 u squared y squared. Yeah, it's as they wrote it. No terms are like. Can't do anything with it. Nice. Alright, then one more of these. And once again, very simple. 12a plus 13b, they're two terms, but they're not like. One has a, the other has b. They don't have the same variables with the same powers on them. So that's it. 12a plus 13b, the way they wrote it, is as simple as it gets. You cannot combine any of those terms. Great, now we just have to do adding, subtracting of polynomials. Alright, so once again, subtraction. So again, subtract this from this. So the second polynomial goes first, then minus that first polynomial. Right, so I'll write this one out again. Alright, there's a lot of space here. I'll just do it here. So that second polynomial, which will go first in my calculation, is negative 10 times m squared minus 11 times mw, and then minus 7w squared, and we're supposed to subtract from this And so minus that first polynomial, the quantity negative 4m squared plus 5mw, and then minus 12w squared. And then just as I've been saying with all these subtraction problems, if you subtract something that has multiple terms like this, you're not just subtracting the first term, you're subtracting all those terms. So it's like you're distributing a -1. And there's no real need for the parentheses around this first polynomial because it's not being multiplied by anything or raised to any powers. So we have negative 10m squared minus 11mw minus 7w squared, and then minus negative 4m squared would be plus 4m squared, then minus 5mw, and minus negative 12w squared would be positive 12w squared, right? Plus 12w squared. And now I combine like terms. Again, you can rearrange them if you want. I'm just going to underline them. Negative 10m squared plus 4m squared would be negative 6m squared. And then here's these mw terms, right? They both have m and w to the first power. Negative 11 minus 5, that's negative 16 mw. And then these w squared terms would go together. Negative 7 plus 12 is positive 5, so I have positive 5 plus 5w squared. And there we go. All right, none of those terms remaining are like. So we have negative 6 m squared minus 16 mw, and then plus 5w squared. Great. And based on my progress, I should have just one more of these. And it's another one where I'm subtracting. This time I'm just going to speak it out loud. This 3u squared minus 5u plus 4, that would go first, and I'm subtracting this second polynomial from it. So I'd have minus 7u squared, minus 10u, and minus 6, right? You distribute the negative. 3u squared minus 7u squared would be negative 4u squared. Right, then negative 5u minus 10u would be negative 15u. And then we have 4 here, minus 6 would be negative 2. Right, and none of the terms I just typed are like, so that's as simple as that gets. Wonderful. Okay, great. And that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, the structure should be similar, so I'm hoping that watching me go through these examples here helps you in some way when you work on the assignment yourself. Alright, and thank you very much for watching.